Hello guys, welcome to a new video of CSAT with Jason. So today we are going to talk about time, speed and distance. If you like this video, please do subscribe, share and support. And if you want to join my Telegram channel, you can join it using the link that I'll be providing in the description box. So let's start with the video. So initially we will look into some important concept that you need to remember in this topic. So the basic equation that you need to remember is speed is equal to distance traveled by time. So this is the most basic equation that you need to study in this topic, and all the concepts that we are going to study, that is the concept of average speed, the concept of relative speed, everything is based on this equation. So this is the most basic one and you need to study this equation. So I'll give you an example. For example, if there is a car and it travels 100 kilometers in 2 hours, then the speed of the car is total distance travel, that is 100 divided by the time taken, which is 2 hours. So you will get 50 kilometer per hour. That means the car is traveling 50 kilometers in 1 hour, and that is the speed of the car. That means the car travels 50 kilometer in 1 hour, 100 kilometers in 2 hours, and 150 kilometers in 3 hours, and so on. So this is the concept of speed, distance and time. Okay. And another thing that you need to remember, or you need to be careful with the questions, is the unit conversions, because in questions sometimes you need to convert kilometer per hour into meter per second, or kilometer per hour into meter per minute, and so on. Whatever the question demands, you need to do the conversions of the units. So normally we represent speed in kilometer per hour or meter per second. Okay, so in order to convert kilometer per hour into meter per second, you need to multiply by 5 by 18. Then you will get meter per second. Similarly, if you want to convert the unit from meter per second to kilometer per hour, you need to multiply by 18 by 5. For example, you have, in the previous example I told you that the speed of the car was 50 kilometer per hour. So this is equal to 50 into 5 by 18 meter per second. So if you solve this one, you will get the 50 kilometer per hour in meter per second. That means how much the car travels, how much meter the car travels in 1 second. So how you got this 5 by 18? Sometimes some students might forget that you need to multiply by 5 by 18. So if you forget this 5 by 18, no, you don't need to worry. You can solve it using the concept. So I'll tell you how to do it. So you have 50 kilometer per hour. Okay, you need to convert this into meter per second. So what you need to do is, you know that 1 kilometer is 1000 meters, right? And 1 hour is 60 minutes, and each 1 minute is 60 seconds. So this will be equal to 60 into 60 seconds. So just write 50 kilometer hour is equal to 50 into 1000 meter, because 1 kilometer is 1000 meter, divided by 60 into 60 second. 1 hour is 60 into 60 second. So just solve this one. You will get 50 into 10 by 36. So if you divide by 2, you will get 50 into 5 by 18. So this is how this 5 by 18 came. And if you want to convert 50 kilometer per hour into 50 kilometer per minute, so according to the question, we'll be doing some questions. So according to the question, you might need to do the conversion. Sometimes the distances will be given in kilometer, the speed will be given in kilometer per hour, but the time will be given in minutes. So in that case, you need to convert kilometer per hour into kilometer per minute. So what you need to do is, you know that, so kilometer, you need it in kilometer, don't do anything here. 50 kilometer divided by 1 hour is 60 minutes. So just divide it by 60 minutes. So you will get it is 5 by 6 kilometer per minute. So this is how you need to do the unit conversions, and the unit conversions are actually very important, because it's going to you won't get the answer if you don't do the conversions correctly. Okay, so this is also very important, and the equation that I told, that is speed is equal to distance traveled by time, that is also very important. Okay. So now let us look into the concept of average speed. So when it comes to average speed, you have different cases. Okay, I'll explain to you the different cases. So you have different cases, and in each of those cases you have different equations. So some students, what they will do is, they will by heart all these equations for different cases, and they will go to the exams, and sometimes the question comes from one of the case. They will confuse, they won't remember what equation need to be used, or they will get confused about different equations. So all those things will happen. So what I suggest you, that I will suggest you not to by heart all those equations. Just remember one thing, that is average speed is equal to total distance by total time. Here total is actually important. I will tell you why. So just remember this equation. By remembering this equation, that is average speed is equal to total distance by total time. Anyway, you know speed is equal to distance by time, right? So just remember average speed is equal to total distance by total time. Okay. So if you remember this equation, you can solve any questions, any cases. Okay. So just remember this equation. Now I will explain to you this equation using different cases, as I already mentioned. So case 1. So in case 1, we'll take an example that a car is there. It travels a distance d with velocity v1, and it travels another distance d, same distance d, with velocity v2. Or it can be like a car travels from point A to point B with velocity v1, and it comes back from B to A with velocity v2. So in both of these cases, the car is traveling equal distance with different speeds. So this is the case 1. What is the average speed when a car travels equal distances in different speeds? Okay, so here there is a formula actually, that is but you don't need to remember, that is average speed is equal to 2 divided by 1 by v1 plus 1 by v2. This is the formula for average speed here. But I will tell you how you got this. You don't need to remember this formula. Just remember this total distance by total time. So in this case, what is the total distance? So in this case, car travels from here to here d, and from here to here it travels another distance c, d. So the total distance will be 2d, right? D plus d, 2d. Now what is total time? So for traveling this much distance, first let us calculate the time. We know that speed is equal to distance traveled by time, or time is equal to distance traveled by speed. So here in this case, the distance traveled is d and the velocity is v1, right? So time will be is equal to d by v1, and that is t1 is equal to d by v1. And for this much distance, the time t2 will be is equal to d by v2. So total time is t1 plus t2, that is d by v1 plus d by v2. Okay, so the equation is average speed. The equation for average speed is total distance by total time. Here total distance is 2d and total time is d by v1 plus d by v2. So you can cancel this d out. You will get 2 divided by 1 by v1 plus 1 by v2. Actually, this is how you got this formula. So don't remember the formula. Just remember total distance by total time. And when a question comes, the question will be saying like a car travels a distance d with velocity 50 km per hour, right? And it travels another distance d with the velocity 40 km per hour. And then what is the average speed? So here just take like this distance as d and this distance as d. Then you will get total distance is equal to 2d, and total time is equal to d by 50 plus d by 40 and all, and then solve the equation using total distance by total time. You will get the average speed. Don't remember these formulas. If you want, you can remember. I'm not saying you don't need to remember, but you can remember this formula if you are okay with it. And if you forget the formula, just remember average speed in any of the cases will be total distance by total time. So I will explain this total distance by total time using different cases. So this is the case 1. Now we'll move on to case 2. So now let us take case 2. So in case 2, a car travels a distance d1 with velocity v1, and it travels another distance d2 with velocity v2. So here distances are different. So no need to remember any formula. Just take total distance. Here total distance is d1 plus d2, and total time will be, here in the first case the time will be d1 by v1, in second case the time will be d2 by v2. So total distance by total time is d1 plus d2 divided by d1 by v1 plus d2 by v2. So in this way you can solve the second case as well. Just remember average speed is equal to total distance by total time. Now let us take case 3. Okay, so case 3 is if the if a car travels distance d1 in velocity v, okay, and another distance d2 in velocity v, then what is the average speed? Here you don't need to solve anything. The car is traveling this distance in velocity v and this distance also in velocity v, right? So that means the car never changes its speed. Then the average speed will be v, or we can try to check it using this equation. Here total distance is d1 plus d2 and total time will be d1 by v plus d2 by v, right? So it will become d1 plus d2 by d1 plus d2 by v. So this will get cancelled, then you will get v. Okay, so this is how you need to solve it. So let us take case 4 now. So in case 4, a car travels for some distance. We don't know the distance. So it is given that the car travels with velocity v1 for time t, and the car travels with another velocity v2 for another time t. Okay, so car travels with v1 speed for time t and another v2 speed for another time t. We don't know the distance. So now we need to find the distance, because the equation is total distance by total time. So we know that speed is equal to distance traveled by time, or distance is equal to speed into time. So here in first case, the distance d1 is equal to v1 into t. In this case, the distance d2 is equal to v2 into t. So total distance by total time will become v1 into t plus v2 into t divided by total time. Here time is t and here time is t. So total time is 2t. So t will get cancelled. You will get v1 plus v2 by 2. So this is like an average, right? Normal average. So normally what happens is that some students, if they see average speed, they will just take the average normally. But don't do that. Use this equation and find out the average. But if the car is traveling with different velocities for equal time t, here the car travels for velocity v1 for this time t and velocity v2 for time t. In that case, the average speed will be like normal average, v1 plus v2 by 2. Okay. So now let us look into the concept of relative speed. That is, for example, if a car is moving in this direction with velocity v1 and a car is moving in this direction, okay, with velocity v2, then their relative speed will be, if the cars are moving in different direction, in opposite direction, then their relative speed will be v1 plus v2, because the person inside the car will feel a velocity higher when it passes the other car. For example, if you are traveling in a train and if a train is coming in the opposite direction, you will feel that the velocity of that train is actually higher than normal. That is because of the relative speed. So if two trains are, or two vehicles, whatever, the car, train, whatever it will be, if they are coming in opposite direction, then their velocity, the relative velocity will become higher. That means the velocities need to be added up. So relative velocity will be v1 plus v2. And if a train or a car is moving in this direction with velocity v1 and another train or a car is moving in this direction with velocity v2, that is, they are traveling in the same direction, then their relative speed will be v1 minus v2. Okay, so this is the concept of relative speed. And normally two kinds of questions are being asked in this from this topic or from this section. That is the questions relating to trains and questions relating to stream and boat. Okay, so we'll be looking into those two questions, and there are different cases in these two questions. So we'll look into that now. So first let us look into the different type of cases when it comes to the relative speed and train. Okay, so case 1 is the questions regarding train and pole or a stationary man. For example, if the questions may be like a train passes a pole and how much time it will take to completely cross the pole or completely cross a stationary man. So in this type of questions, what you need to do. So let us take, this is the train and this is the length of the train, which is L, and the train is traveling with a velocity v. Okay, and there is a pole here. There is a pole here. So we need to find out the time, how much time it will take to cross this pole. And this train is traveling and the train reached here. Okay, the train reached here. So train is now here, okay, and it started to cross the pole. So if the train is here, it starts to cross the pole. So when will it completely crosses the pole? If the train is like this, it moved and the back side of the train came here near to the pole, right? So in this way it completely crossed the pole. And how much distance it have covered now? So train was here, the front of the train was in this position when it started to cross the pole, and now the front of the train is in this position. So it traveled this much distance, which is the length of the train itself. So here speed will be is equal to distance traveled, which is L. Speed, we know that the speed of the train was V, right? So V is equal to distance traveled. If let us assume that the T is the time taken to cross the pole, so by T. So time taken to cross the pole will be length of the train divided by the velocity of the train. So this is the first case. So now let us look into the case 2. So this is train and a bridge and a tunnel and a platform. So in the first case, the train was crossing a pole or a stationary man. So pole or a stationary man doesn't have length, or the length is very much low and it is negligible when it compared to the length of the train. But when it comes to a bridge, tunnel or a platform, they have a length. So that is important here. Okay. So let us take this example. So a train is there. The length of the train is L, okay, and velocity of train is V, and there is a bridge. So this is a bridge, and we want to find, this can be a bridge, it can be a tunnel, it can be a platform, whatever it may be. So we want to find out how much time will it take for the train to cross this bridge, okay. So let us assume that the train is here now. That means the front of the train is here. It just started to cross the bridge, okay, and so this is here. Now let us assume that the front of the train reached here. So train will be like this. So did it cross the bridge? No, it didn't cross the bridge. The front came here, but still the train is in the bridge, right? So if it needs to be completely crossed, the train should exit the bridge. So this is the second case, and then the train became like this, okay, that is the back side of the train is here. So now it crossed the bridge, right? Now how much distance the train covered? It covered this much distance. Now the front of the train is here. In the initial case, the front of the train was here. Now the front of the train is here. So it covered a total of this much. This, let's assume that the length of the bridge is B and length of the train was L. So this is L. So it covered a total distance of B plus L. So here speed V of the train is equal to total distance covered by it, which is B plus L, and let's say that T is the time taken by it to cross the bridge, that is T. So this is the equation that you need to use here, okay. Now let's take case 3, train and train, or two trains. So two trains, I already told that if a train is moving like this with velocity V1 with length L1, and another train is moving like this with velocity V2 and length L2, then we know that the relative speed will be V1 plus V2, and the length, the total distance covered by these two trains to cross each other will be L1 plus L2. So here you need to use the formula V1 plus V2, that is the total velocity. This is equal to total distance by time. Distance will be L1 plus L2 because they need to cover each of their distances to cross each other. So L1 plus L2, if T is the time taken for that, it will be L1 plus L2 by T. And if the trains are traveling in the same direction, for example, if there is a train, first train is like moving like this with velocity V1 and length L1, and second train is also moving in the same direction with length L2 and velocity V2, then we know that relative speed will be V1 plus V2, assuming that velocity V1 is greater than velocity V2. Then V1 plus V2 is equal to L1 plus L2, that is the distance covered divided by time. So you need to use this equation. Now let us look into the last case here, that is a train and a running man. For example, a train is moving like this with velocity V1 and length L1, and a man is moving in this direction with velocity V2 and he doesn't have a length because the length of the man is negligible, right? It's there is no length. So here what happens, this is they are running or moving in the opposite directions, right? So velocity, the relative velocity will be v1 plus v2. So here you need to take v1 plus v2 is equal to total length. Here only the length of the train will come. So let's say this is L. So L divided by time taken to cross, this is equal to T. And if the man is running in same direction of the train, in this direction with the velocity v2, then their average speed will become v1 minus v2. Then the equation will become v1 minus v2 is equal to L divided by T. So in this way you need to solve the problems of train. Okay. So now let us look into the concepts of our questions from stream and boat. So let's say there is a stream like this, that is a river or a stream, and it's flowing in this direction with the velocity s. So the velocity of stream is s, and we have a boat here. It is moving in this direction with velocity b. Let's say the velocity of boat is b. So here what happens is that since the boat is moving downstream, so downstream means moving in the direction of the flow. So boat is moving with the direction of the flow. So the velocity of flow will aid the movement of the boat, right? So here velocity, total velocity or the effective velocity will be b plus s, because the stream will also aid the movement of the boat. So here velocity will be b plus s. So in this type of questions you need to take velocity as b plus s. And if the boat is moving upstream, okay, if there is a stream or a river like this which is flowing in this direction with velocity s, and there is a boat which is moving in this direction, okay, in this direction with velocity b. So it is moving against the flow. So if a boat is moving against the flow of the river, its velocity will become less. So here the velocity you need to take it as b minus s. Okay, so these are the cases, and then everything is same. You just need to take the velocities as b plus s for downstream and b minus s for upstream. Okay. So now let's solve some questions. So this is a question from UPSC 2021. A person X starts from place A and another person Y starts from place B, and they set out at the same time to walk towards each other. So let's say this is A and this is B, and a person X started moving like this and person Y started moving like this, right? The places are separated by a distance of 15 kilometers. So this is 15 kilometer. Okay. X walks with a uniform speed of 1.5 km per hour. So this is 1.5 km per hour. X is moving with 1.5 km per hour. And Y walks with a speed of 1 km per hour in the first hour. So in first hour, it is traveling 1 km per hour. That is the speed. And then with a uniform speed of 1.25 km per hour in the second hour. In the second hour, it is traveling with 1.25 km per hour. And with a uniform speed of 1.5 km per hour in the third hour. So in third it is traveling with 1.5 and so on. That means in fourth it will be 1.75, in fifth it will be 2, like that. Now which of the following is correct? So we need to check when they will meet, because it says, first statement says they take 5 hours to meet. So let's say in first hour X travels 1.5 km, because in each hour it is traveling 1.5 km. So in first hour it reaches 1.5 km mark. Okay. And B on the other hand, in first hour it reaches 1 km, because initially in the first hour it is traveling with 1 km per hour. So it reaches 1 km mark. In the second hour it is traveling with a uniform speed. X is traveling with a uniform speed. That means it will travel 1.5 km more. That is, it's reached 3 km mark. And B in the second hour it travels 1.25 km. So it reaches 2.25 km mark. Now in the third hour it will reach 4.5 km mark, again 1.5 more. And B, what happens is that it travels 1.5 km in the third hour. That means it reaches 3.75 km mark. That is 2.25 plus 1.5, which is 3.75. And in the fourth hour X travels 1.5 km more, so it reaches 6. And in the fourth hour Y travels 1.75 km. So 3.75 plus 1.75 is 5.5 km. So Y travels 5.5 kilometer, and in the fifth hour x travels 1.5 kilometer more. That means it will reach 7.5. Actually this is 15 kilometers, so 7.5 is the half of 15, which means this is the middle point. So x reached the middle point, and when it comes to y, it travels 2 kilometer in the fifth hour, so it will also reach 5.5 plus 2 is 7.5, so it also reached the 7.5 kilometer mark. That means in fifth hour, after 5 hours, both of them are at the center, right? That means they take 5 hours to meet, and they also meet in the midway. That means both 1 and 2 is the right answer. So now let us look into another question. This is from UPSC 2020. A car travels from place X to Y. So let's say this is X and this is Y. So a car travels from X to Y with a velocity v km per hour. It from Y to X at an average speed of 2v km per hour. So it came back from Y to X with a velocity 2v. Then again from X to Y at a speed of 3v. It went again like this at a speed of 3v. And again from Y to X at a speed of 4v. So it came back again with a velocity 4v. Now we need to find the average speed of the car. Okay. So here you don't need to remember any formula. As I said, average speed is equal to total distance by total time. So let's assume the distance from X to Y is d. So in this case it traveled d. In the second case it traveled d. In the third case it traveled d. In the fourth case also it traveled d. Right? So total distance will be 4d. Divided by, in this first case the time will be d by v. Second case the time will be d by 2v. Third case time will be d by 3v. And fourth case it will be d by 4v. So you can cancel this d out. Now the LCM of v, 2v, 3v, 4v is 12v. So we will make the denominator 12v. So it will become 4 divided by 12 plus 6 plus 4 plus 3 divided by 12v. So this is going to become 4 into 12v divided by 18, 22 and 25. So that is equal to 12 into 4 is 48. So 48 by 25v. So here if you see the options, it is like less than 4 v kilometer per hour, lies between v and 2v kilometer per hour. We don't need to find the exact value. So we got that this is 48 by 25v. 48 by 25 will be 1 point something, right? Because 25 into 1 is 25. 25 into 2 is 50. So this is only 48. It's not 50. So this is like around 1.9 v or something. Okay. We don't need to find it exactly. Okay. So we know that 1.9 is between 1 and 2. So option is, correct answer is B. So let's look into another question. A and B are two railway stations 90 km apart. So let's say this is A and this is B, and they are 90 kilometers apart. Okay. A train leaves A at 9 a.m. So there is a train. It leaves from A at 9 a.m. and it headed towards B at a speed of 40 km per hour. So it is moving at 40 km per hour. A train leaves B at 10:30. So a train is there. It leaves B at 10:30 and it's heading towards A at a speed of 20 km per hour. So this is moving at 20 km per hour. Then find the train meets each other at. So we need to find the time when both trains meets each other, right? So what is there is train from A and train from B. In 1 hour, train from A travels 40 kilometers because speed is 40 km per hour, and train B travels 20 km. In half an hour, train A travels half of it, that is 20 km, and train B travels 10 km. In 1/4 hour or 15 minutes, okay, 15 minutes, train A travels 10 km and train B travels 5 km. So let's keep this table here. Okay, now let's solve the problem. So here from B the train travels starts only at 10:30, but from A the train already started at 9 a.m. So first thing that you need to find out is that at 10:30 a.m. that is the time when the train from B starts, what is the position of train from A. Okay, so that is from 9 a.m. to 10:30 there is 1.5 hours. So in 1.5 hours train A travels 40 km in 1 hour, and in the half an hour it travels 20 more kilometer, that is it travels 60 kilometers. So train A will be somewhere here. The train from A will be somewhere here, that is this is 60 km. It traveled 60 km. So balance is 30. So that means at 10:30 a.m. At 10:30 a.m. there will be 30 kilometer between trains from A and B. Now it is at 10:30 a.m. right? And if you look into the options is there is 10:45 a.m., 11:45 a.m., 11 a.m., etc. So in next 15 minutes, that is at 10:45 a.m., train A travels 10 more kilometer. So it travels 10 more kilometer and B travels 5 more kilometer, right? So this is only 10 plus 5, 15. Still there is 15 kilometer between them. So 10:45 is not the right answer. Okay. Then again in next 15 minutes, okay, next 15 minutes, train A travels another 10 kilometer. So it travels another 10 kilometer and train B travels 5 more kilometer. So that becomes 15. So 15. So option B is the right answer. So this way you need to solve this kind of questions. Now let us move on to another question. Find the length of the bridge if a train 200 meters. So length of the train L is equal to 200 meters and speed is 60 km per hour. Speed is equal to, or velocity is equal to 60 km per hour and crosses it in 36 seconds. So time is equal to 36 seconds. So here you need to remember one thing. The velocity is given in kilometer per hour. Time is given in seconds and the length or distance is in meters. So first thing that you need to do is you need to convert the speed into meter per second. So velocity 60 kilometer per hour is equal to 60 into 5 by 18 meter per second. So let's keep it like that. Okay. Now speed is equal to, speed is equal to distance traveled by time. So speed 60 into 5 by 18 is equal to distance is, this is 200 meter length of the train. Let's assume that length of the bridge is B. So it will be, distance traveled will be 200 plus B into divided by distance traveled by time. Time is 36. So 200 plus B is equal to 36 into 60 into 5 by 18. So this will become 2. That is, it will become 600. Right? Then B is equal to 600 minus 200, which is equal to 400 meters. So let's solve one more question. A 125 meter long train passes a man running at a speed of 5 km per hour in the same direction in which the train is going in 10 seconds. So the train is going like this with length is equal to 125 meter and the man is running in the same direction in 5 with speed 5 km per hour. Then the train crosses this man in 10 seconds. Okay, then speed of the train is. So here again the speed is given in kilometer per hour and but the time is in seconds and the length is in meters, or the distance is in meters. So first you need to convert kilometer per hour into meter per second. Okay, then what is the velocity here? The relative velocity. If the velocity of train is V and they are moving in the same direction, relative velocity will be V minus 5. So V minus 5, and we need to convert this into meter per second, that is 5 by 18. This is equal to, speed is equal to distance traveled by time. So distance will be 125 divided by time will be 10. Okay, so V minus 5 is equal to 125 into 18 by 5 into 10. Okay, so here you can cancel it out. 5, this will become 25, then again 5, this will become 5, then will become 9. So 9 into 5 is 45. So V minus 5 is 45. Then speed of the train V is equal to 45 plus 5. Then it will become 50 km per hour. So answer is 50. So guys, thank you so much. I'll be coming with another video. And if you like the video, please do subscribe, share and support. Thank you.